So my dear children, now we are about to conduct the activity, and within this activity we will be measuring several forces by using the spring balance given here. So this is the instrument called the Newton balance or the spring balance in simple, right? Newton balance or the spring balance. So here you can clearly observe that this spring balance is calibrated from Newtons. Here the scale, over here the scale is calibrated from Newtons, and over here you can observe it's been calibrated from grams as well. So here within this one, right, within this one you can observe the calibration is done by using grams plus Newtons both, right? So these types of spring balancers are the ones that we are using in our laboratories, spring balancers or the Newton balancers. Right now we are about to measure the gravitational pull given by the earth on this piece of rock which I have here. Okay, so in order to measure that, by using the piece of thread, I have prepared a hook. Now let's insert this thing and we'll measure it. First of all, I'm going to take a good knot here so that I can hang the hook of the spring balance. Okay. So right now I'm going to check the gravitational pull given out by the stone by using the spring balance like this. Okay, so now we need to keep it horizontally like this. Right, as you can see here, now the rock is above the ground level and it is hanging, right? And you can see that the reading of the spring balance now have moved, it has been moved up to like how much in newtons. So it has a reading around 1.8 newtons. 1.8 newtons. So the rock over here is showing a 1.8 newton of a reading. That's the gravitational pull. The gravity or the gravitational force acting along the acting towards the earth is pulling this rock at a force of 1.8 newton. 1.8 newton here, right? 1.8 newton. Okay then. So my dear children, our first reading, the gravitational pull given by the rock was 1.8 newtons. 1.8 newtons. Now I have, so let's keep it in a different place. So now I have a wooden block here with me. Now I have fixed the hook onto the wooden block so that I can drag it along the surface. So while I'm dragging it along the surface, I'm going to calculate how much the horizontal force which I need to give in order to like start the motion of the object. I'm not going to move it like very fast. I'm just going to start the motion of the wooden block, that's it, by applying certain force. Right, now I have inserted this thing. Now by using the spring balance, I'm going to check how much of a force do I need to apply in order to move the object. I'm not going to move it very fast, remember. I'm just going to move it, just going to start the motion. So as you can see here, now the reading is up to 2 Newton. 2.1 Newton. Two 2.5. So once again, let's see. I'm going to keep it in here. Get a reading at the place where the motion starts. So yes, here 1.5, 2 newtons, 2 newtons. Now the reading is at 2 Newton, and you can see that the object is going to start the motion. Just start the motion. Once again, see, 2 newtons, 2 newtons. Yes, at 2 newtons of a force, right, at 2 newtons of a force, object is just starting to move. Yes, when the marker runs greater than 2 Newton, it's suddenly going to start the move. So at around 2 Newton, you can see it clearly, our wooden block is going to start the motion. So that's the force which I have applied to just start the motion of the wooden block. So here it's nearly, we can round it off to nearly 2 Newton, right? 2 Newton. So earlier the gravitational pull given by the rock was 1.8 Newton. Now to slightly move the wooden block, we had to apply 2 Newton of a force. 2 Newton of a force. Right then, now what we are going to do is, we are going to hold this thing horizontally, firmly on the table, and we are going to apply, we are going to use that spring, helical spring, and we are going to apply a certain force in order to increase the length up to 10 centimeters, up to 10 centimeters. Okay, then I'm going to measure out the force which I need to exert on the spring in order to increase the length up to 10 centimeters. Right then, so I have with me, right, I have with me the materials which I need to conduct the third stage of the activity. So this is the one which is referred as the G clamp, my dear children. As it is in the shape of the letter G, this is referred as the G clamp. By like tying up this lever, we can tie any kind of a thing or fix any kind of a thing to a support by using the G clamp. So here, now in here I have fixed a ruler to the tabletop so that I can measure the length up to 10 centimeters. Okay, so I'm going to take this helical spring and fix it onto the hook here. Here you can observe the reading is at exactly 10 centimeters. So I'm going to increase the length of the spring, helical spring which I have here, up to 10 centimeter of a length. Okay, so first of all, I'm going to fix this. By using the G clamp, I'm going to fix this thing to the tabletop first. Okay, so it's firmly fixed to the tabletop. So this is the ruler. As you can see here, this is 10 centimeter of a length, 10 centimeter of a length. So first of all, I'm going to insert the spring here, right? So now let's take the distance to 10. Okay, now it's exactly at 10, aligning with 10 centimeters, right? It's aligning with 10 centimeter mark, as you can see here. Now I'm going to insert the Newton balance. Here we go. Then I'm going to push towards that side. I'm going to apply a certain force and pull this thing, right? So let's pull up to 0. Right. Here we go then. So children, as you can see here, now I have stretched it up to 10 centimeters. Now the reading is exactly at 3 newtons, right? Reading is exactly at 3 newtons. 3 newton of a force is being applied on the spring now to stretch it up to 10 centimeter of a distance, right? 3 newtons. Right. So we got the reading that was necessary when conducting or when applying forces, right? So we took the gravitational pull given out by the earth on that particular rock as 1.8 Newton. Then in order to move this wooden block horizontally, right? Just start to move the wooden block. I had to apply 1.2 Newton of a force. 1.8 was the gravitational acceleration, a gravitational pull given out by the earth on that particular rock. Here I apply 2 Newton of a force in order to move the wooden block horizontally. Just start to move. Okay, then to increase the length of the spring up to 10 centimeter of a distance, I had to apply 3 Newton of a force. So these are the 3 cases and these are the 3 readings which I have took from the activity. So let's head on to the classroom and we'll fill out that table from our observations. To identify the direction of the force which is going to apply on a certain object, I have with me, my dear children, a wooden block. So I have fixed a nail onto this wooden block and once again there is a thread. Okay, now first of all we need to keep the wooden log like this. Now so I'm going to take the thread and keep it horizontal like this. Now I'm going to push it. Okay, I'm going to apply a certain force on here on the thread and I'm going to pull it towards towards my hand, right? So let's pull it and observe what's going to happen. So as you can see here, now the thread is horizontal, okay, and I'm going to pull it. So you can see here when I'm pulling it, the thread is at a horizontal level, right? Thread is at a horizontal level when I'm pulling it. See, once again. So when I'm pulling it, thread is at a horizontal level and the object is also moving horizontally along the thread or along the direction of the thread. See? Okay. So from this observation you can say that along the direction where the force is going to act, for the same direction the object is going to move. Right. Now I'm going to keep the block in here, and I'm going to now, earlier we drag it horizontally, now I'm going to change the direction like this kind of a direction. Okay, now I'm going to turn. Right, so you can clearly observe now when I'm dragging the thread, or when I'm pulling the thread, you can clearly observe the wooden block is turning towards the direction which the force is going to apply. See, it's very simple. Towards the force, the wooden block is going to turn. See, it's going towards the direction which the force is being applied. Okay, so in the earlier case, when I'm going to apply the force horizontally like this, I'm going to pull it horizontally, it's going to move horizontally. When I'm going to keep it like here and drag it like this, then it's going to it is turning, or it is going to a side, or it is traveling to the side, same side which I'm going to apply the force. Not horizontally, but it's showing some kind of an angle, right? So here you can see that according to the direction which I'm going to apply the force, right? According to the direction which I'm going to apply the force, the object is going to turn and travel, and object is going to turn and start the motion. If the force is horizontal, then the motion is also horizontal like this. Okay, horizontal motion. If the force is like leaned toward some kind of a direction, then the motion is also going to lean towards some kind of a direction, right? Okay, so my dear children, from this activity it is obvious to us that according to the direction of the force which is applied, the object is going to move. So let's head on to the classroom and we'll write down our observations from the experiment. So my dear children, now in here, this activity, we are going to use two different objects. Here I have with me a wooden circular shaped wooden object, and this is a wooden block. Okay, now first of all, I have pinned 3 tinted nails on the wooden block here, and they are fixed with a piece of thread like this. So I'm going to first of all, then if you can see here, the wooden disc also is fixed to a thread like this. Now this thread is fixed to the iron nail which is on the center of the disc, and I have marked 3 directions, 1, 2 and 3 on the wooden disc. So first of all, I'm going to keep this thing away and I'm going to take the wooden block. Now there are 3 threads, 1, 2 and 3 along 3 different directions. Now I'm going to apply certain forces on each of these 3 nails, and I'm going to pull it and drag along this tabletop and see when I'm going to apply the force, what's going to happen with the direction of motion. So first of all, we'll apply the force from here, from this thread. So as you can see here, when I'm applying the force from that thread, the object is moved along the direction of the thread. Once again, from this thread, I'm going to apply a force. So along the direction of that thread, okay, the object moved. Third one. So as you can see here, along the direction of the thread, the object is going to move. See? Object is going to turn to the direction of the force and then it's going to travel towards the direction of the force. It's quite simple. So here also, according to the direction of the force which is being applied, you can clearly see that the object is going to move, my dear children. Right? So I have applied forces along 3 different locations. So these 3 points are the points of application of forces. So along the direction of the force which I am going to apply, right, on each of these threads, the object was moved. Right? So that was our observation. Now we'll keep this wooden block in a separate place. Let's take the second object, our disc. So disc, as you can see here, this is the thread. Now I'm going to turn it towards number 1 and I'm going to pull it gently. So as you can see here, the object is now traveling towards number 1. And you can see here very clearly, right? You can see here very clearly, the thread is also directing towards number 1. Along the direction of number 1, the thread is also being kept, right? See? The object is moving towards number 1. Now, I'm going to change the direction. Number 3. So as you can see here, now the object is moving towards number 3 and the direction of motion is pointing, the thread is pointing towards number 3 and the direction of the motion also towards number 3. Now, once again, number 2. Direction of motion is towards number 2 and the thread is also directing towards number 2. Once again, see, number 3, number 1, number 2. See, according to the direction which I am going to pull, see, according to the direction which I am going to pull the object is getting moved. From this activity, right, from this activity you can say that irrespective of the shape of the object, according to the direction which the force is being applied, the object is getting moved. And according to the same direction, right, according to the same direction, the thread is also moved. It's actually not moving, but it is directed towards the area or the place or the direction which the force is being applied. Object over here is going to move towards that direction which the force is getting applied. So here it is obvious to us that according to the direction of the force, the motion of the object can be observed irrespective of the shape of the object. Right then, so let's head on to the classroom once again and we'll write down our observations and then conclusions of the activity.